In this problem, we're given a quadratic function and we're asked several questions. This is at least the third video I think I made about this problem. So in case you think I'm going a little too fast at the beginning, maybe you should watch one of the other ones, because I'm going to kind of breeze through the beginning here since I've done two other videos in this. So the coefficients a, b, and c are the numbers in front of the x squared term, the x term, and the constant. So a is defined to be the number in front of the x squared. So in our problem, a lines up to be with 1/3, b lines up with the -2, it's the number in front of the x, and since there's no number at the end, you're supposed to assume c is 0. So a is 1/3, and b is -2, it's the number in front of the x, and c, since there's no constant at the end, that is 0. So the next question says, graph the function on your calculator. That's not too hard. So you go to your calculator, and if you turn your calculator on, it starts where you're on the home screen. Press y equals, clear out any old functions, and type in this one. I advise that you put the 1/3 in parentheses, and then you have x, and then the squared key's right here, and then subtract 2x. And I'm just going to press zoom 6. If you press zoom 6, the zoom key gives you this here, and number 6 is zoom standard. So you're telling the calculator to graph the function in a standard window, which is -10 to 10 on the x-axis as well as the y. So I get this parabola. It asks on number 3, since I'm done with 2, I graph the function, does the graph open up or down? Well, it certainly opens up, like the regular letter U in the alphabet. And the reason it did that is because our a was positive. In fact, our a was 1/3. Whenever your a value is positive, you're going to get a parabola that opens up. So it opened up because a was bigger than 0. A being bigger than 0 is just another way of saying a is positive. It tells me to, number 4, write the vertical intercept as an ordered pair. A vertical intercept is always where the input is 0. And if you watch the video, I showed that when you plug 0 into any quadratic, you always get out c. So 0, c is going to be my vertical intercept. So in our case, c, if you remember right, was 0. So this is a special case for the vertical intercept. So our vertical intercept is going to be simply when you plug 0 in, everything drops out, and you have nothing left, and you have just 0 there. So our vertical intercept is 0, 0. So I'm going to write that as an order pair as it asks me to, left parentheses 0, 0, and I have to hold the shift key to get that parenthesis in, don't I? So that's running through the first 4 questions. That's a bit fast, but I do it much slower in the other 2 videos that I made. The next part, number 5, plot the vertical intercept on the graph using the point tool. That takes no time at all. You click on the point tool, and the vertical intercept in this case was 0, 0. The one that eats up a little more time is to do number 6, and that really is what this video was meant to be about, is part 6, to draw the function neatly. The harder part is finding the highest or the lowest point on this one. And it's not that much more difficult than the other videos, but it is slightly different in that you have to deal with a fraction. So if you've watched my other videos, or hopefully your teacher showed you this, that to find the highest or lowest point on the parabola, since our parabola opened up, it looked like this. To find the lowest point, it's called the vertex, and that vertex, at least the x value of that vertex, can always be found by taking the opposite of b and dividing by 2 times a. If you're using your graphing calculator on the home screen, I advise you to put parentheses around the 2a and make it look like that. So that'll always be the input of the vertex, is what that formula always gives you. So this one's just a little bit different because a is a fraction, and I thought I'd do a video just because of that fact that a was a fraction. So our opposite of b, so our input for the vertex is going to be the opposite of b. In our case, b was -2. Since b is -2, the opposite of b would be +2. So far I've got +2 in the numerator. Then I'm supposed to divide by 2 times whatever a is, and our a was 1/3. So you get a little bit of a complex fraction here, and I thought that was enough to merit another video. So what you get here is 2 divided by 2 times 1/3, remember the 2 is in the numerator, so when you multiply the tops and the bottoms, you get 2/3 here. How in the heck do you take 2 and divide by 2/3? So to write that horizontally, it looks like this, and you have 2 divided by 2/3, and what you need to do is take that the division symbol, change it to a multiplication, and reciprocate this fraction, make it 3/2. So it turns out it actually comes out quite simple. You've got multiplication by 2. In fact, you could think of this as 2 over 1. You've got multiplication by 2, division by 2. That simplifies out to be the number 1. So basically, you end up with an input of 3 here. So all of that to say that the input of the vertex is 3. And now you need only plug 3 back into the original equation to get the corresponding output. So there is a formula for the output of the vertex. It's just really ugly and hard to memorize. So it's easier just to go back here and replace x with 3. And what you'd get out of that, boy, that looks messy. Let me kind of erase all this stuff now, and suffice it to say the coordinate that I found of the vertex had an x value of 3. It would be really fast to go to your calculator, since we'd already graphed it, hit trace to get some coordinates here, type in 3, hit enter, it does the arithmetic for you. When you plug in 3, you get out -3. I just thought that I was a little better than that and would plug 3 in by hand. So if you plug 3 in by hand, not looking at this one, but this up here, you'd have f of 3 equals 1/3 times 3 squared, and then minus 2 times 3. In fact, if you wanted, you could even think of that that one of these 3's cancels with one of the 3's. However you want to simplify this out, but maybe you want to do it this way and just say that 3 squared means 3 times 3, that's 9. And then 2 times 3 is 6. And then 1/3 times 9, remember the 9's in the numerator here, so you're really taking 9 dividing by 3, that's 3. You've got to subtract 6, and on a good day, 3 subtract 6 is -3. Do not ask me what it is on a bad day. So I get, when you plug in 3 into the original equation, you get out -3, and that would be our vertex, which in this case is our lowest point. So you go back to the graph, and it says plot it neatly by first plotting the lowest point using this poly tool. So you do have to click on the poly tool. My lowest point was 3, -3. So here we go, 3, -3. That's going to be the lowest point. And move up, because our parabola opened up. And we had to pick some other point. It said one other point. But we know it goes to the point 0, 0. So I'm just going to pick that one as my second point. And it's a little different than the other videos I made, but not much.